All right, so let us practice and look at problems that have liquid-vapor mixtures. All right, a rigid tank contains 10 kilograms of water at 90 degrees C. If 8 kilograms of the water is in the liquid form and the rest is in the vapor form, right, that tells you it's a liquid-vapor mixture, then determine the pressure in the tank and the volume of the tank. All right, so what property table should I go to? It's in SI units, so I'm in Appendix 1. It is water, so I'm in 4, 5, 6, 7. It is, some of it is liquid, some of it is vapor. It's a liquid vapor mixture. In order for it to be both liquid and vapor mixture, it's saturated liquid, saturated vapor. We're in a saturated table, 4 or 5. And we're given temperature, so the temperature is table A4, right? Table A4 is the table that I'm going to go to. All right. The pressure in the tank. Well, if it was saturated liquid, it only has one pressure. If it was saturated vapor, it only has one pressure. If it is a saturated liquid vapor mixture, it only has one pressure for that temperature. It's a 1-to-1, right? And so I would go to this temperature and I would find P sat for 90 degrees C. I think we actually did this table. All right, so for water, so I'm in Appendix 1. I'm in water, so I'm in 4, 5, 6, or 7. It's saturated, so I'm in 4 or 5. And I'm given the temperature, so I'm in table 4. 90 degrees C, that is the saturation pressure. That is the pressure. 70.183. 70.183. You go back and look at the units. They were kPa, kilopascals. Okay. Then the volume of the tank. Well, the property table is not going to give me the volume of the tank, but I bet you the property table could give me the specific volume of the tank, right? The property table is not going to give me the volume, but it can give me the specific volume, and then I think with the mass, I can figure everything else out. So, what specific volume should I use? Should I use 2.3593 or should I use 0.001036? Or is it somewhere in between the two? Yeah, it's somewhere in between the two. How far in between the two? I need to calculate the quality X. I need to calculate the quality X. So the quality X is mass vapor over mass total, not mass liquid over mass total, not anything else, but mass vapor over mass total. Write that on your formula sheet and double check, make sure you're doing that correctly. All right, so this would be, let's see, all right, a total of 10 kilograms. 8 kilograms is in the liquid form, so what is this? 2 kilograms is vapor. Didn't explicitly tell us that, but we could figure that out. Over the total of the quality is 0.2, right? If we have 10 and 8 of it is still in water, it only has a quality of 0.2. It's 20% of the way in mass of going from liquid to vapor. So quality is 0.2, right? X is 0.2. Now I bet I can get the average specific volume. That's not exactly what it's asked for, the total volume, but first I'm going to get specific volume. Average specific volume is VF plus X VFG. VF, all right, so the average would be VF. I go back to the property tables. VF is 0.001036. VFG, this one doesn't tell it to us. Just because these are so large and these are so small, this middle column would practically still be the saturated vapor values. And some teachers would have you just use the saturated vapor values for VFG. It's not going to really change your answer, but I like to subtract the two. So I'm going to, all right, so there's VF, there's VG. So let me go back to our notes. VF was 0.001036, and be careful not to accidentally leave out a 0 or something. That would throw off your numbers a bit. Plus quality times VFG. All right, so we didn't have a column for VFG, so I want us to do this manual. 2.3593 minus 0.001036. Yes, it's going to be practically 2.358. Do that. Some would also not care if you added this or not. I like us to do the same thing for every problem. V would be 0.473 meters cubed per kilogram. I was about to box that in. That's not exactly what it asked for. It didn't ask for the specific volume. It asked for the volume. So big V, let's see. V equals V divided by M. Multiply it times the mass. Let's make sure those units make sense. If I take that, multiply it times the mass, I would get big V. Yeah, 0.473 meters cubed per kilogram times the total. All right, so this is the average. If it were a homogeneous total, a full 10 kilograms, and all 10 kilograms had that average specific volume. All right, so this, when I do V equals MV, this is the total, and this is the average right here. All right, 4.73 meters cubed. 4.73 meters cubed. And you could have done this a little bit longer route. See if you get the same answer. A little bit longer route if you took that, you know, and if you said 0.8 times the VF value, 0.2 times the VG value, and add them up, you'd still get 0.473. All right, so let's take a step back and look back. I had to make sure I was in the right property table. I knew it was a mixture. I could calculate the quality just by given the masses that they told me. And then I used V equals VF plus X VFG to find the average specific volume. If it was a homogeneous mixture that all the particles had an average specific volume of that, then I'd take the mass of all the particles to get the volume. Remember that, you know, property tables give you specific volume. Many times, though, you are asked for total volume.